example 5, we are to solve the equation 3x minus 5 modulus equals to 2 minus a half x. The very first thing that we should start with is sketching the graph of y is equal to 3x minus 5, and of course reflected along the line y is equals to 0, or the x-axis, and again sketch the graph of y is equals to 2 minus a half x. So therefore, if you would wish to tabulate this x and y, you will be able to know that when x is supposed to be, let's say, 0, then y is minus 5, and the modulus of y is supposed to be positive 5. When x is supposed to be, let's say, 2, 6 minus 5, we have a 1. When x, we have 6 minus 5 is a 1, and y modulus is obviously a 1. But it is the point whereby the graph crosses the x-axis is very critical for us, because we know at that point then we are going to have the vertex, because that is where the graph is going to be reflected along. So therefore, when y is 0, we have 3x minus 5, and this gives 3x is equals to 5, and therefore x is going to be 5 over 3, or rather 1 and 2/3. So without any other kind of work, let us try to sketch this one. At x is equals to 1, 2, 3, 1, 2, and 3. When x is 5 over 3, that means 1 1/3, y is going to be 0. When x is going to be 2, we have y 1, 2, 3, 4, 5. 5, 4, 3, 2, and 1. When x is 2, we can see y is 1, moving that way. It's a straight line. When x is 0, y is supposed to be minus 5, and minus 5 reflected along the x-axis becomes positive 5. So that is kind of the graph we are going to talk about. Of course, you can see this part is the original part, and this is the reflected or the moduled part of the graph. Having said that, now we also need to probably sketch the graph of y is equals to 2 minus a half x, and since this one is a straight line, we only need 2 points. When x is 0, what is our y? So 2 minus 0 is 2. When x is, let's say, 2 minus 1, because a half times 2 is 1, 2 minus 1 is 1. But at some point, x can also be negative value. Of course, minus 2 should have started, but it's okay. We only need, when x is negative 2, 2 minus minus 1, we have a 3. When x is a minus 2, y is supposed to be positive 3. And when x is a 2, y is 1 for that matter. And when x is 0, y is 2. So we have a straight line that talks about that. So this is the line y is equals to 2 minus a half x. Of course, this is the graph. This shows y is equals to 3x minus 5 modulus. How does we capture one thing? At some level, it would not have been necessary to sketch this, because you would have just taken the positive aspect of this and solve the value of x, and the negative aspect of this, and of course solve the value of x. Let's say you can see at point A, the two graphs meet at this point A. The graph y is equals to 2 minus a half x and the moduled part. So we are going to effect this part with the negativity. At point B, this point, the two graphs meet or the original part, the positive part, before it was reflected. This part is after it was reflected. So let's see, at point A, we are having minus 3x minus 5 equals to 2 minus a half x. Opening this, because it is the molded part, so we have to bring the negative part or the negative sign, simply because it was supposed to be, the line is supposed to be generating or produced this way. It's only that there's a reflection along the x-axis. That is why we are bringing the negative sign. So opening the bracket, minus 3x plus 5 is equals to 2 minus a half x. And you can see, probably we have, if you bring this side, we're going to have 5 minus 2 is equals to minus a half x plus 3x. 3x minus a half x is simply 2.5x, and we can simply say 2.5 is 5 over 2. 5 over 2x is equals to 3. So what is x times 2 over 5 times 2 over 5? So x is supposed to be 6 over 5 at this particular point. At what point? At point A, x is supposed to be 6 over 5. If you consider point B, let's just work it out here. Point B, we are going to have 3x minus a 5 equals to 2 minus a half x. This is the positive part of it, so we are not going to introduce the negative sign. And of course, we are going to have 3 plus a half. We're going to have 3.5, which is 7 over 2x equals to 2 plus 5, which is a 7. And of course, to make x the subject, we multiply both sides by 2 over 7 times 2 over 7, and this cancels out, and x becomes just 2, because 7 and 7 will cancel out. So you can see at this point x is equals to 2, and at point A, x is equals to 6 over 5. And both of these become the solution of the original question, which was shown up there. Okay?